You'd think a sealed, vacuum-pumped steel box, right, like completely shielded from heat and radiation, is basically the definition of empty.
Right, you would think so.
But quantum mechanics tells us that that quote-unquote empty box is actually boiling with invisible energy.
Yeah, it's fundamentally not empty.
Exactly. So today we're taking you on a deep dive into a massive stack of sources to see if humanity has actually figured out how to tap into that boiling box. We're looking at declassified Defense Intelligence Agency reports, military tech journalism from the war zone, Nick Cook's investigative work in the hunt for Zero Point, and some hardcore physics explainers.
It's a really necessary thought experiment, I think, because, the gap between theoretical physics and this sort of military aerospace folklore is just massive.
Oh, totally.
So we're going to stress test this in 3 steps today. First, we look at whether these technologies are physically grounded in reality at all. Second, if they do exist, we apply economic game theory to see why they wouldn't just be mass commercialized.
Right, the whole suppression myth.
Exactly. And third, we analyze the likelihood that these concepts are actually human-engineered versus, say, the result of attempts to reverse engineer unidentified anomalous phenomena.
Okay, let's unpack this, starting with that boiling box.
Yeah.
I mean, my understanding of zero-point energy, or ZPE, always felt a bit like, comic book science.
Yeah, it sounds like sci-fi.
It really does.
Yeah.
But it's fundamentally tied to the Heisenberg uncertainty principle, right? Like the idea that because of quantum uncertainty, space can literally never be truly empty or perfectly still.
That is the foundation, yes.
What?
Heisenberg dictates that you can never simultaneously know the exact position and momentum of a particle.
Right.
So if a system were completely empty and at absolute zero, its position and momentum would both be exactly zero, and quantum mechanics strictly forbids that.
It's just not allowed by the math.
Nope. So even in a perfect vacuum, there is this mandatory baseline of fluctuating energy. Think of the surface of the ocean, right? Even on the calmest, most windless day imaginable, the surface is never perfectly glass flat. There is always a microscopic underlying ripple, a kind of quantum static of virtual particles just popping in and out of existence.
And if you're listening to this and wondering, why your high school physics teacher never mentioned that the universe is boiling with infinite energy, it's because it's largely invisible to us.
Mostly invisible, yeah.
But we can physically measure it,
Yeah.
right? I mean, the Casimir Effect is the classic example in our sources.
Yeah, the Casimir Effect takes it entirely out of the realm of pure math. It was discovered in 1948, and the principle is basically that if you place 2 uncharged, perfectly conductive metal plates incredibly close together in a vacuum.
Like, how close are we talking?
We're talking micrometers apart, extremely close. They will actually be pushed together by the vacuum itself.
But let's break down the why there, because it's not some magic gravity pulling them. It's wave mechanics.
Precisely. The quantum vacuum is full of electromagnetic waves of all possible wavelengths. But that tiny microscopic gap between those 2 metal plates, it can only fit certain very short wavelengths.
Right. The longer waves literally cannot fit inside that physical gap.
Exactly. So you end up with the full spectrum of quantum waves pushing on the outside of the plates, but a restricted, much weaker spectrum pushing on the inside.
And that pressure differential physically forces the plates together.
You got it. It's physical kinetic force.
Wait, okay, if the vacuum is physically pushing 2 metal plates together, I mean, that's kinetic energy. Why can't we just attach, a microscopic lever to those plates, let them snap together, harvest the power, and boom, infinite clean energy?
Well, you're skipping over a pretty massive thermodynamic cost there.
There's always a catch.
Always. Our How Stuff Works source breaks down exactly why that idea falls apart. To extract energy from any system, you have to move it from a higher energy state to a lower energy state.
Like water falling down a dam.
Perfect example. But zero-point energy is, by definition, the ground state. It is the lowest possible energy level in the universe. You cannot pull water from a dam if the water is already at the bottom of the ocean.
Right, because if you pull energy out of the ground state would have to drop even lower.
Which quantum mechanics explicitly forbids.
Okay, that makes sense.
The DIA report we reviewed categorizes this really brilliantly, actually. They separate the engineering concepts into Type I and Type II machines.
Okay.
What you just described with your microscopic lever is a Type I machine, a one-shot extraction.
So it works once?
Right. You let the Casimir plates snap together and you get a tiny spark of energy. But to reset the mechanism, to pull those plates apart against the relentless pressure of the quantum vacuum, you have to expend more energy than you just generated.
So friction and inefficiency just eat your profits. You always lose.
Always, every single time. What the science fiction crowd wants is a Type II machine.
Which is what exactly?
A device that continuously extracts energy from the vacuum on a steady-state basis without consuming itself. And the rules of quantum electrodynamics, or QED, completely forbid that.
So if thermodynamics mathematically blocks us from harvesting the quantum vacuum for power, that closes one huge door. But it forces us to look at the other side of the equation, right? Propulsion.
Right, the anti-gravity side.
Exactly. If we can't extract energy from space, can we manipulate the fabric of space itself to move? Now, our audience already knows general relativity. Gravity is mass energy bending space-time.
It pulls, it doesn't push.
Right, it always attracts. To get repulsive gravity, metric engineering tells us we would somehow need to generate negative mass.
Yeah.
Which is, a mathematical placeholder, not a physical reality we've ever actually found.
No, we've never observed negative mass.
So how are all these historical defense contractors proposing we completely bypass the need for negative mass?
Well, historically, they weren't bypassing it. They were honestly just misunderstanding electromagnetism.
Really, just a misunderstanding.
Yeah, look at Thomas Townsend Brown back in the 1920s. He built these devices he called gravitators, which were essentially high-voltage capacitors that appeared to lose weight when you pointed them in a specific direction.
Okay.
He spent decades pitching this Electro-Gravidics concept to the military as true anti-gravity.
But our sources say modern physics completely debunked Brown's work as just being ion wind.
I want to pause on that, because how does pumping electricity into a capacitor create a physical breeze strong enough to lift something?
Because it's brute force chemistry, not metric engineering.
Okay, explain that.
When you pump extreme high voltage into an asymmetrical capacitor, the intense electric field literally strips electrons off the nearby air molecules.
Oh, wow.
Yeah, so those air molecules become positively charged ions. They violently repel from the positive anode and race toward the negative cathode. As they race across that gap, they crash into neutral air molecules, dragging them along.
Oh, so it creates an actual physical downdraft.
Exactly. It's essentially a solid-state electric jet engine. It's just moving air. It's not bending space-time at all.
Not even a little bit. When NASA ran their breakthrough propulsion physics program in the late 90s, they rigorously tested these electrogravitic concepts, and they categorized them as definitively non-viable for space travel.
Because in space, there's no air.
Exactly. Once you put them in a vacuum chamber where there's no air to ionize, the thrust drops to absolutely zero.
Which sets up a pretty glaring contradiction for our deep dive today. If QED says zero-point extraction is impossible, and general relativity says anti-gravity is functionally impossible without negative mass,
Yep.
why does our source material show the United States military and these massive aerospace giants spending like 70 years trying to do exactly that?
I mean, the paper trail is staggering. The War Zone details how George Trimble, who was a vice president at the Glenn L. Martin Company, the predecessor to Lockheed Martin, he actively recruited physicists in the 1950s specifically to conquer gravity.
And it wasn't just him, right?
No, the Air Force's aerospace research laboratories at Wright-Patterson published huge studies on field propulsion. We have the 1972 Project Outgrowth report. The pursuit literally never stopped.
It really hasn't. Look at the Salvatore Pez patents filed by the Navy just recently.
Oh, the Pez patents. Yes.
High-energy electromagnetic field generators, hybrid aerospace underwater craft. I mean, the claims in those patents are just wild.
They are. But the Pez patents are a perfect case study in the how of this theoretical physics.
How so?
Well, the core mechanism Pace proposes relies on the piezoelectric effect. Certain materials, when you pulse electricity through them, rapidly change shape and vibrate.
Okay.
Pace theorizes that if you take these materials, spin them actually at extreme speeds, and vibrate them electromagnetically at incredibly high frequencies, the sheer kinetic agitation will interact with the quantum vacuum.
Basically, he's arguing you can whip the vacuum into a localized plasma shield to reduce inertia.
That is the claim, yeah. But let's apply our game theory here, because we have to look at the development of literally any human technology.
Right.
Aviation didn't go from the Wright Flyer directly to the F-22 Raptor in complete secret.
No, of course not. You had biplanes, monoplanes, early turbojets, swept wings.
Exactly. There is always an iterative trail of technological maturity.
The fingerprints of human engineering.
Yes, the fingerprints. If humanity had successfully engineered anti-gravity or zero-point energy from the ground up, we wouldn't just have theoretical Navy patents.
We would have intermediate steps scattered all over the industrial record.
And we simply don't. The data we actually have is sobering. The Purdue University engineering source notes that the Casimir force being measured in advanced labs today is roughly 0.013 dynes for two small plates separated by a micrometer.
0.013 dynes. What is that in practical terms?
To put that in human terms, that is about one-thousandth the weight of a housefly.
Wait, really? One-thousandth of a housefly?
Yes.
So we are struggling to lift a fraction of a fly in a billion-dollar lab, and yet the folklore claims we have secret underground hangars full of flying saucers.
It's a huge disconnect. And Nick Cook's investigation in the hunt for Zero Point really supports this stark reality.
Right, because he spent years looking into this.
He did. He spent years penetrating the Black Project Aerospace world. And what he found wasn't a fleet of advanced craft.
What did he find?
He found a technical breadcrumb trail of theoretical math, institutional obsession, and endless dead ends. There were zero smoking guns of mature functional technology.
Okay, here's where it gets really interesting for me. Let's pretend, just for the sake of the game theory, that someone did figure it out.
Okay, let's pretend.
Say a major defense contractor secretly cracked the Pace patents, or they built a Type 2 zero-point machine. The immediate conspiracy theory that everyone jumps to is suppression.
Ah, yes, the suppression myth.
The idea that powerful entities like Big Oil, OPEC, or the national security apparatus are deliberately hiding these technologies to protect the status quo. I mean, I absolutely do not buy that.
You shouldn't, because the economic realities detailed in the sources don't support the suppression myth at all. It assumes a fundamental misunderstanding of how energy infrastructure actually works.
Exactly. The idea that you would hide a literal infinite energy machine to protect the crude oil industry is it's like an early tech company inventing the internet, but then locking it in a vault to protect the fax machine industry.
That is a brilliant analogy.
It makes zero economic sense.
Yeah.
Just because the energy is sourced to the zero-point vacuum doesn't mean the energy is suddenly free to the consumer.
No, not at all. You are still dealing with profound infrastructure costs. If you invent a zero-point reactor, you still have to manufacture the exotic materials for the core, right?
Right.
You have to build the quantum grid, the substations, the distribution networks. It's an entirely new utility. It requires billions in capital just to scale it.
You'd still get a power bill every single month. It would just say quantum vacuum instead of natural gas.
Yeah.
And if this tech requires massive capital to develop, the people funding it are going to want a return on their investment. Logically, the biggest investors in zero-point energy would be the oil cartels themselves.
Absolutely. Think about OPEC. If they possessed this, they would patent the infrastructure, commercialize it, and transition their entire business model away from finite, politically volatile crude oil
to absolutely dominate an infinite energy market.
The incentive to commercialize is just overwhelming. And that same logic totally dismantles the anti-gravity suppression theory, too.
Because of the logistics applications.
Yeah. If you possess a technology that can manipulate mass, you don't hide it in a classified hangar. You revolutionize global logistics. You change commercial aerospace, deep-sea shipping, heavy construction overnight.
The financial incentives for applying these discoveries publicly just far outweigh the benefits of keeping them locked away purely for quote-unquote national security.
And even that national security argument falls apart under scrutiny.
No.
Because if the Pentagon secretly has an anti-gravity fleet, they use it to project absolute, undeniable global dominance. They don't hide it for 70 years while simultaneously spending trillions of taxpayer dollars building conventional jet fuel-burning aircraft carriers and F-35s.
Yeah, it's such a good point. Which brings us to the logical conclusion of the first two steps of our thought experiment.
Right.
The physics blocks easy extraction, there are no human fingerprints of iterative development, and the overwhelming profit incentives dictate that if we had this tech, it would be commercialized.
So therefore, neither zero-point energy nor anti-gravity is currently available for human use.
Okay, so what does this all mean? If the tech isn't being suppressed for profit, and we clearly didn't invent it from the ground up, but we still have a mountain of credible, high-level people, military whistleblowers, radar operators, who swear up and down that these capabilities actually exist in our airspace. Where's this coming from?
This brings us to step 3, the UAP connection.
Let's hear it.
If we accept the premise that anomalous craft demonstrating anti-gravity or infinite acceleration are physically operating on Earth, but human science lacks the thermodynamic and metric engineering fingerprints to build them, the highest mathematical likelihood is reverse engineering.
Okay.
It implies technology that is physically here, but that human science is fundamentally incapable of harnessing yet.
It's like handing a modern, fully functioning nuclear reactor to a 19th century steam engineer.
Oh, I like that.
Right. Because they can clearly see it generates immense heat.
Yeah.
But because they entirely lack the scientific framework of quantum physics or radiation theory, their only instinct is to try and figure out where to shovel the coal.
Yeah.
They can tinker with that reactor for a century in secret, and they won't reverse engineer it. They'll just end up with radiation sickness.
That is a phenomenal analogy. It really bridges the gap between possessing advanced technology and possessing the underlying scientific paradigm required to actually replicate it.
And it perfectly aligns with our sources, doesn't it?
It does. It aligns perfectly with the sociology of secrecy that Nick Cook uncovers in his book.
How so? Because the secrecy itself seems to be part of the failure, right?
It is the primary catalyst for failure. Look, when institutions try to study world-breaking physics under extreme compartmentalized secrecy, they cut themselves off from the broader scientific community.
There's no peer review.
None. If a physicist working on a black project hits a dead end, they can't publish a paper to have 10,000 other physicists tackle the problem. Progress just stalls.
Right.
And worse, inside those dark silos, whispers become folklore. Legitimate scientific dead ends like struggling to lift 0.013 dynes with the Casimir Effect mutate over decades of rumor into a myth about a secret, fully operational flying saucer fleet.
So we arrive at a truly fascinating crossroads here. Are UAPs a complete myth generated by an echo chamber, or is the military actively using them as a deliberate misdirection?
Well, based on the game theory of our sources, it is highly probable that both realities coexist simultaneously.
Oh, so it doesn't have to be a binary choice.
Not at all. On one hand, you have highly credible testimony, backed by multi-sensor radar data and highly trained observers, suggesting that anomalous craft UAPs truly do exist.
So we may very well possess recovered materials that act exactly like that nuclear reactor given to the steam engineer.
We have the hardware, but not the paradigm.
Exactly.
But on the other hand, the narrative of exotic recovered tech is an incredibly powerful tool for military intelligence. It can be actively leveraged as a smokescreen.
Oh, I see where you're going with this.
Think about it. If an aerospace contractor is testing highly classified but entirely conventional next-generation stealth drones, letting the public and foreign adversaries think they are seeing alien anti-gravity craft is the ultimate cover story.
That is a brilliant double bluff.
It really is. Furthermore, the UAP mythos serves as a really convenient mask for institutional failure.
Because it's embarrassing to admit they've failed.
Exactly. It is politically much easier for the defense apparatus to let the folklore of "we have secret UFOs" spread than to sit in front of a congressional oversight committee and admit that they've spent 70 years and billions of dollars utterly failing to crack the physics of the quantum vacuum.
Wow. So they lean into the sci-fi myth to cover up their conventional secrets while simultaneously masking their exotic failures. I mean, that is incredible game theory.
It really makes you view the whole phenomenon differently.
It definitely does. Let's pull all of this together for the listener. We started with a mission to pressure test the holy grails of zero-point energy and anti-gravity. And what we found is that while the physics of the quantum vacuum is a proven boiling reality, the jump from vibrating microscopic plates to harvesting infinite energy just completely violates our current grasp of thermodynamics.
The math demands a tool we can't pay.
We looked at the 70-year military paper trail from Townsend Brown's ion wind to the Pace patents and realized that humanity lacks the iterative technological fingerprints of success.
Right, there are no intermediate steps.
And when we applied game theory, the massive profit incentives of energy commercialization and global logistics completely shattered the conspiracy that big oil or the government is secretly suppressing a working anti-gravity fleet.
It just doesn't make economic sense.
So if this technology truly exists in our atmosphere, the lack of human fingerprints strongly points to UAPs, that our scientific paradigm is simply too primitive to reverse engineer. a reality the military gladly uses as a convenient smokescreen for their own operations.
It grounds these massive science fiction concepts in the stubborn realities of thermodynamics, economics, and human sociology.
It does.
But before we close the books on this thought experiment, there is one final, staggering piece of physics from our sources that flips this entire conversation on its head.
Okay, lay it on me. I love a good twist.
It's known in astrophysics as the cosmological constant problem.
The cosmological constant problem.
When physicists use our absolute best quantum field theories to calculate exactly how much zero-point energy should exist in the vacuum of space, the number is astronomically huge.
Makes sense.
But when astronomers actually measure the expansion of the universe to calculate how much vacuum energy is physically there, the number is incredibly tiny. The theoretical prediction is 120 orders of magnitude larger than the observed reality.
Wait, 120 orders of magnitude. That's like a 1 with 120 zeros after it.
Yep.
That isn't just a rounding error.
Yeah.
It's a completely incomprehensible gap.
Mainstream science calls it a mathematical discrepancy. They often refer to it as the worst prediction in the history of physics. They assume our equations are just fundamentally incomplete.
Right.
But if we follow today's thought experiment to its absolute most provocative, sci-fi extreme, what if it isn't a math error?
Oh, man. Let me guess. What if the energy was actually there, but something happened to it?
Precisely. What if that zero-point energy isn't missing because of a misplaced decimal point in human mathematics? What if it's missing because something out there in the cosmos has already figured out how to extract it?
Wow. That is an incredible thought. We started this deep dive talking about pumping everything out of a solid steel box, realizing the empty space was actually boiling with quantum energy.
Yeah.
But maybe when we look out at the vast empty box of the universe and measure the energy, someone else has already drained the ocean.
Exactly.
That is definitely something for you to mull over the next time you look up at the night sky. For now, that's our deep dive. Keep questioning the physics, keep exploring the paper trails, and we'll catch you next time.